Hey guys, in this video, we're going to go over functions and domain and range. So on your notes, I have your book definitions for function, domain, and range. And then I wrote over here what I think is more helpful and makes more sense. But your book's definition of a function is a relation that takes one input value and assigns one and only one output value to it. So what does that mean? That means that your X can't repeat. And when I was teaching high school, I would say that X can't cheat. Okay, we don't care what Y is doing. We don't care if Y has 1X, 2X's, or 3X's. We just care about that X, and we know that X cannot repeat. So if you like that definition better, pause the video and write that down. And then domain is the set of all possible input values, or in other words, your X values, while range is the set of all possible output values, or those are your Y values. So if you like those better, write those down. So example 1, we need to state the domain and range of the following relation, and then we'll determine whether the relation represents a function. So a relation is just a set of ordered pairs. I pointed at function, but a relation is just a set of ordered pairs. So here we have a relation. We got a bunch of ordered pairs here. And first we need to determine the domain. So the domain is all of our X's. So I am looking at 0, 1, 2, and 3. And so when we write this, when we write a set of numbers, a set of individual numbers, we need our fancy squiggly brackets, and then we will list 0, 1, 2, and 3 and close our fancy squiggly brackets. Our range then is all of our Y coordinates. So we've got -2, 3. I have 2 3s right here. Okay, I don't care about that. I'm only going to write 3 once, because once I write -2 and 3, well, now 3 is already in my solution set, so I don't need to rewrite it. And then 7. So this one only has 3 numbers because 1 repeated. So then the question is, after I find the domain and range, what is the function, or is this a function? When I'm determining if this is a function, I am only looking at my X's. Does my X repeat? No, it doesn't, because X does not repeat. That means that this is a function. So is it a function? Yes. Okay, let's repeat on B. We need to list the domain and range. Again, domain is X. So squiggly bracket, because we're listing individual numbers. We've got 2, -3, 4, and 2. So I have 2 here twice. So I'm not listing 2 in my set twice. So 2, -3, and 4. Close your squiggly brackets. Okay, and one thing to kind of notice here, on this side, they went from least to greatest. If you want to put these in least to greatest, you can, but it really does not matter. So I'm just listing these in the order that these ordered pairs are given to me. My range, squiggly brackets, are my Y. So you've got 7, 6, 9, and 10. So then, is this a function? Again, when I'm determining if it's a function, I only care about X. Does X repeat here? Yes, it does. We have a 2, and we have a 2. So this is not a function. Over here, when Y repeated, we had 2 3s. That didn't matter. Y can do whatever it wants. But X has to stay faithful. Okay, so this is how we find the domain and range and determine if it's a function when I'm given a set of ordered pairs. When I have a graph, I'm going to determine if it's a function by my vertical line test. The vertical line test is the set of all points in an XY plane is the graph of a function if and only if every vertical line intersects the graph in at most one point. So in example 2, determine whether or not the graph is that of a function by using the vertical line test. In either case, use the graph to find the domain and range. So by my definition, it's a function if and only if every vertical line intersects the graph in at most one point. Well, when I put a vertical line in right here, this is intersecting at more than one point. So this is not a function. Even though I can put a line in right here, right on the edge of the circle and get 1 here, it says in my definition that every vertical line must intersect at one point. So just because I can find one place where it does intersect once, that does not mean that it is a function. If I can find anywhere on that graph where it is crossing twice, then it's not a function, because what this is stating is that my X value right here is repeating. This is, I should have done this in a little bit different spot, but this is essentially negative 1.5 in a number and negative 1.5 in another number down here. Okay. So then my domain, when we write these as a domain, I can't, well, let's just go over this. Okay. So the domain is your X. And when I do X, here's my X axis here. I always want this to be least to greatest. I don't care up here when it is just random numbers. Okay, but when it's with a graph, this needs to be least to greatest, and we can do that by going from left to right. So you want to take your pencil and go from left to right. Where is this graph intersecting, or where is my pencil finally intersecting this graph at? Well, right here at 2. And then as I keep going from left to right, what is the biggest number that I get? Well, that's right here at 2. So it should be negative 2 to 2. So my domain is negative 2 to 2. Bracket because those numbers are included. And we have to use interval notation here because I cannot possibly list all of these numbers. Not only is this domain made up of negative 2, negative 1, 0, 1, and 2, but it is again, it has all of these infinite numbers in between those whole numbers. I cannot list every number from negative 2 to 2. So I'm going to use interval notation to say every number between negative 2 to 2 is part of my domain. Okay, so now let's do the range. The range has to do with the Y. When we do range, because I'm doing an interval notation, because it's a graph, and I need this to be least to greatest, we're going to go bottom to top. So I'm going to take my pencil and go from the bottom up to the top, and that will assure that I get the least to the greatest. So as I'm taking my pencil and going from bottom to top, what's the smallest number I am encountering on this graph? That happens to be negative 2. And then what's the biggest number I happen to encounter on this graph? And that is 2. So my range is also negative 2 to 2. Now, while this is a great example for the first one, this is also a bad example for everything to come. These numbers are not my answers because that's where it's crossing this axis. It just so happens that this is the lowest value on my Y, and this is the highest value on my Y. This happens to be the lowest value on my X, and this happens to be my highest value on my X. Okay. This is a little bit better of an example. When I'm finding domain and range, not only do I need to find domain from left to right and range from bottom to top, but when I get arrows, arrows equal negative infinity and positive infinity. Okay, and we'll see an example of that here. So first, let's determine, is this a function? And we'll use our vertical line test. Does every vertical line intersect only once? No matter where you put a vertical line, you're only going to touch this graph one time. So this is a function. Okay, so let's find domain and range. To find the domain, we're going to go left to right. When I am going from left to right, the first thing that I am touching here is this arrow. Because the first thing I am encountering is an arrow, this is negative infinity. What's confusing about graphs is that when you look at this graph, what direction is this graph going? Most of you guys are going to say up, right? Going up here and it's going up here. But not only is it going up, it is also going out further. As this graph continues, it's going to get wider and wider and wider. So as this graph is going up, it's also going to keep expanding along this x-axis. I've got -2, I've got -3, I got -4, I've got -5. I can get a -6 and a -7 if this graph keeps going up and out. So it is never going to stop getting smaller along this x-axis. Same thing with my x. When I am going from left to right, the last thing that I am encountering is this arrow, which means this is infinity. Because again, as this is going up, it is also going out. So I've got 3, I've got 4, I've got 5 on this graph, I've got 6 on this graph, I've got 7 on this graph, 8, and I can keep going forever as this graph continues. Okay, so let's try our y's. For the range, we need to go from the bottom to the top. So when I take my pencil and I go from the bottom to the top, where am I encountering this graph first is right here. I don't care that it's crossing my y-axis over here at 9. The lowest point is right here. And what is that lowest point on the y? That's -3, and -3 is included. It's that point right there. And then as I go up, the last things I encounter are an arrow here and an arrow here, which means it's going to keep going up forever. So I'm going to have all of these positive y values. I've got 10, I've got 11 on this graph. I've got 12, 13, 14, 15. It's going to keep going up forever. But after this -3, or before this -3, when I go down here to -4, that graph never touches. It never touches a -3.5. The lowest number on that range is -3. Now we're going to keep going and do more examples of finding the domain and range for graphs in later videos. And we're going to keep doing this the entire class. So you need to get good at finding the domain and range. If you did not fully understand these 2 examples, keep watching videos. We're going to do, I think, like 5 more examples, and hopefully you start picking it up as we do more examples. These concepts are hard. but once you get them, you will get them. So just stick with it. Don't give up.